Hey there kids, welcome to another math video. This is for Eureka Math, grade 5, module 2, lesson 27, homework. And if you would like to check the objective, what you should be able to do by the end of today's lesson is to divide decimal dividends by 2-digit divisors while estimating quotients. While reasoning about the placement of the decimal point and making connections to a written method, we call that the standard algorithm. Also thinking about, what are we doing here? I'm taking 7 of something and dividing it into 28 groups. Like, what kinds of numbers are you dividing with anyway? Well, you should be able to divide any number by any amount, because you can divide a big number into small things or divide a small thing into many pieces. So this is a small thing being divided into many pieces. You can't just switch the location of these pieces around. 7 is your whole. That is the dividend. That is being divided into, let's say, 28 groups. And that's the way it's going to be, which means that the size of each group is going to be very small, less than 1. And that is my expected answer. So now we're working with decimals, and we're going to use the standard algorithm with our little check. So put these in the right places and go watch the problem set video if you don't know what you're doing yet, because you need to make sure that you are doing what you're supposed to. So first thing, 7 is inside the bracket. That's right, it is. 28 is outside the bracket. Yes, in fact it is. This is your divisor outside. We can do this by annexing a decimal, and let's just put a couple of zeros. If we don't need that extra one, we'll get rid of it. So I'm going to take my 7 and divide by 28 and say, nope, can't happen. This is why I know I'm going to have a number that's a decimal. 70 is now what we're dividing. 70 tenths divided by 28. If I had about 30, I would do 30/60, and I would have 2. Using the 2, 2 times 8, 16, 2 times 2 is 4 plus 1 is 5. Now it's just that same old process. Find the difference between 56 and 70. You can count up, or you can use the standard algorithm. Sometimes I just count up and I go, well, it's 4 more to 60 plus 10, so that's 14. 14 is less than 28, bring down the 0. Now I have 140 and I need to divide by 28. So roughly 30, 3, 6, 9, 12, maybe 50, because I have, yes, that'll actually, I'm doing mental math in my head. 5 times 8 is 40, and then I know that that's 10 plus the 4, so that gives me 14. So, hello, Bob. We named him Bob, the 0 at the bottom. Everybody gets so happy when we have Bob. Bob came by for a visit. Now we're going to check with 28. And so do your standard algorithm. 8 times 5, 40, carry the 4, 16, and 4 is 20, carry the 2. It goes up, it falls down. And then we hold this spot with a 0 because we're done with that. 2 times 5, 10, carry the 1. 4 plus 1 is 5, and then 2 times 0 is 0. You don't have to put that there, but let's put it there for business purposes. Okay, bring down 7, but it's not 700, it's 7 hundredths or 7 ones, because it's 2 places here up in the problem and therefore 2 places here. Make your connection, put a star. Okay, so lots of steps. You should be getting better at this. Remember, when you set up your numbers, it has to be in this order. 25 is on the outside, 51 is on the inside. Now, you might say, well, this is so easy. Why are they doing this for us? Okay, well, 2 25s, yes, make 50. But when you have one left over, we're going to continue by annexing a decimal and zeros. And notice what happens if you have something that is less than your divisor. You must hold this place with a 0. Continue dividing by bringing down another one. And notice now that I have 100, which is divisible by 25, exactly 4 times. Close those zeros, okay, which gives us, hello, Bob. So it gives us nothing left over. So 2.04 is your exact answer. So no more of those remainders hanging around. It's really much better and more precise to use exact decimal division and carry it out a couple additional steps. Multiply to check. 4 times 5 is 20. The 0 goes down, 2 goes up, falls down. 2 times 5, 10. Next row, hold that spot with a 0. Get on over to the tens place. 2 times 4 is 8. 2 times 0, 2 times 2. Add them up. 10, carry it over. And then you have 5, 1, 0, 0. 2 places here, 2 places here. Connect, check, star, continue. 13 on the outside. 6.5 on the inside. Decimal up. Carry it up right away because we don't have to annex the decimal and zeros. Here's the decimal, and they're telling you. And we might have to add some zeros at the end, but let's see how well we do here. So 6 is not divisible by 3, so you're going to hold that spot with a 0. Then move over to the 65 tenths. Do your division by dividing by the 16. Skip count maybe with like 15, 30, 45, 60. But I have less than that, so it's either 4 or 5. If I have a 5, look at that. 5 times 3 is 15, carry the 1. 5 times 1 is 5 plus 1 is 6. Little mental math in your head can help save you from having to do a lot of erasing. I even added the extra 0. We don't even need it. Okay? Your check, I'm going to use 13 on top and 0.5 on the bottom because I have a 0. So 5 times 3, or 3, yeah, 5 times 3 is 15, carry the 1. 5 times 1 is 5 plus 1 is 6. But this has a decimal here because there's a tenth here times 1s, so we need a tenth. And then look, we actually match exactly. So just a couple things that they're training you to do. You can move things around. It can have a different look. You can switch the location of your factors because factor times factor equals product no matter where you put them. Unlike in division, you cannot move that dividend. The dividend is what you have to begin with. 16, 132.16, decimal up, put it in place and get ready to go. 13 can't be divided by 16, so you got to use the 132. If I knew that that was pretty high already, I'm going to start with like an 8 or a 9. Probably, let's say 8, 48, 8, 9, 10, 11, 12. Let's try an 8. 6 times 8 is 48. Carry the 4, and then 8 times 1 is 8 plus 4 is 12. So I'm really close here. The difference between 28 and 32 is 4. You can use the standard algorithm if you don't like doing it that way. This place value positions still matter. This is now 1/10 that's being divided by 16. 2 16s would be 32, and then I don't have enough room for another one. So put a 2 here. 2 times 6, 12, carry the 1, and then 2 and 1 is 3. And the difference between 32 and 41 is 9. You can use the standard algorithm if you prefer. But here comes the 6. Now I have 96, and I'm thinking that's almost exact. Yes, 6. 6 times 6, 36. Carry that 3 over, and then, of course, 6 times 1 is 6 plus 3 is 9. So just a little thinking. Hello, Bob. Little thinking can help you not have to erase too much. 8.26 times 16. 6 times 6, 36. 12, 13, 14, 15, 48, 49. 6, 2, 8. Add 6, 11, 10, 12, 12, 13. But carry this 2 places, 132.16. What a relief that I got the right answer. I was going a little bit fast there. Hopefully not too fast for you smart kids out there. All right, set this one up. 28 into 5, 6, 1.68, decimal up. And then we can get started. This is about 30, but it's a little bit less, 2 less in fact. And so if I have 2 of those, 8 times 2 is 16, 2 times 2 is 4 plus 1 is 5. I actually get nothing left over. But they did this on purpose because they want you to see that when you bring down, that you have not enough to divide. So I'm going to bring down again. And guess what? You still have not enough to divide. 16 tenths cannot be divided by 28 by any amount. So continue all the way over until you have enough to divide. That's the trick with this problem. Now I have 168 hundredths that I'm dividing by 28. Thinking about things that end with 8 and roughly 30, so I'm thinking 5 or 6, but a 6 times 8 is 48. Carrying the 4 over, 6 times 2 is 12, plus 4 is 16. I have 0. Hello, Bob. I have 0 left over. Now I have a quick and easy check using the standard algorithm on my 4x2 with a lot of zeros. 6 times 8, 48, goes up, falls down with a 0, and then 16. Hold that spot. 2 times 6 is 12. The 1 goes up, comes down, a 0, and then 4. Cramming it all in here. 1, 6, 5, 5, 6, 1, 6, 8, 5, 6, 1, 6, 8. 2 places of decimal to the right here, 2 places here. Quick check, and there's not even any wiggle room. Okay, hooray, star. Last one. 36 into 604.8. Decimal up. All right, we have enough to get 136 into 60, but not anymore. If it's too much for you, use the standard algorithm. I've been kind of skipping around on that. I have 24 left over. That is okay. It's still less than 36. Bring down. Now I have 244 divided by 36. If I was to use 40 and skip count, 4 times 6 would be 24. I have a little bit less, but probably not enough. So let's do 6 times 6, 36, 18, 19, 20, 21. And that's going to be a big leftover, but take 1, give 10, 8, and 2. Shoo! Just made it. 28 and bring down your 8. 288 is now our dividend. That's all that's left. It's 288 tenths. If you would like to put your decimal there, you may. And then divide by 36. It's kind of a big amount. I'm going to guess, again, it's got to be bigger than 6. So let's try 8. 6 times 8, 48. Use the 4. And then we have 24, 5, 6, 27, 28. Hello, Bob. 3 digits here. 16.8 times 36. A 3 by 2. But it's tenths by ones. I feel like my light's going to go out here soon. 8 times 6, 48. 36 and 4 is 40. 6 plus 4 is 10. Put the 0 there. 24, 18, 19, 20. 3 and 2, 5. Add. Phew, 6048 and 1 place here and 1 place here. There you go. Star. Happy. Moving on to word problems. Moving right up. Okay, sorry, I'm checking time. Yes, I am. Okay. In a science class, students water a plant with the same amount of water. That is division right there. Each day for 28 consecutive days. If the students use a total, here, knowing the total, division, of 23 and 8/10 liters of water over the 28 days, how many liters of water did they use each day? It's such a tape diagram. Can you see it? Here's the total. And it's over 28 days. So you can, I don't know, I kind of go back and forth. 1, 2, ... 28. Okay? This is your 28 days. But it says the same amount of water. So what we don't know is the amount. So we're going to divide our 23.8. But watch out. The question, it says how many liters of water did they use each day? And then also how many milliliters. So if you take your 28 and I'm going to restate that. Take your 23 and 8/10 and divide by the 28. We've been really working on reading these problems accurately. And so say the total divided by the piece. Set that up like so. Decimal up, because you've got to have your decimal in place. We're not going to annex a decimal. It's already there, so you're not going to add anything. You only get 1 decimal in place value. Now, 23 is not divisible by 28, so put a 0 there. And you have to use the whole 238 tenths. This is kind of a lot, so I'm thinking it's going to be an 8 or 9. If I think about an 8, 8, 64, 8, 16, 16, 7, 9, okay, I'm going to try 8. I think I'm going to have just the right amount, 64. Carry the 6. So I've got 16, 19, 23, 22, 22. Holy moly. Subtract 4, 1. Okay. So what is that? Well, that's 8. And I need to have an exact answer because I know that I'm using up all these liters. Here's where you can annex your 0. Bring it down and continue. You have 140 hundredths now. Let's see if we can finish out and find Bob. Find Bob. We're on a quest for Bob. We want a 0 at the end. So if I had roughly 30, 3, 6, 9, 12, let's try 5 because look at that. 8 times 5, that's going to give me that 40. There go the lights. And then I have 5 times 2 for 10 plus 4 is 14, and that's where I get my exact answer. Hello, Bob. Okay, so what is this? This is going to be your days. This is your total amount of liters. So this is going to be the liters per day. Now that's this answer, but you also have to convert it to milliliters. So here's one answer, but take your 0.85 liters and you have to convert to milliliters. So that's using a conversion formula. Remember, okay, this is good review, people. Take what you have, multiply by 1 of the old. Take what you have and multiply by the equivalent of the new unit. 1 liter is equivalent to 1,000 milliliters. So it's going to be a 3-position shift of the digits. The digits go left, the decimal goes right, 1, 2, 3. So that would be 850 milliliters each day. Now you have both answers. Oops, liters there, milliliters there. Heh. Erase that. And we'll move on. Okay, any questions about that? Anyone? Anyone? It's so quiet in here. Okay. Number 3, a seamstress has a piece of cloth that is 3 yards long. She cuts it into shorter lengths of 16 inches each. How many of the shorter pieces can she cut? Let's start out with a tape diagram. It's 3 yards, the fabric, which notice the change in units here. Just convert right away, would you please? Okay, if 1 yard equals 36 inches, you have to maybe think about it as 12 inches equals 1 foot, and then 3 feet equal 1 yard, and then take your, whatever you have to do, but you got to know this, memorize that. It's all over the tests, everywhere, all the tests. So she cuts it, okay, take your 36 inches, cuts it into shorter lengths of 16 inches each. How many pieces? So it's going to be 16 inches, if you can see that, 16 inches. How many times? Okay, so that's what a tape diagram does. It helps you see the parts and the whole. So I want to use my, I need to know, it's not just 36 inches for 1. It's 36 times 3 because it's 3 yards. 3 yards, 36 inches for 1. 6 times 3, 18, 9, 10. 108 inches in all. Inches in all. There you go. Get that? How about that? Okay. 108 inches equals 3 yards, 36 inches in 1. Why don't we just take that out? It's already up here. Okay. So now you have your 108 inches, and we're dividing it into pieces that are 16 inches each. That's your divisor. This is your dividend. So 10 not divisible by 16, but 108 is. How many times? roughly 15, 26. Let's guess, because 6 times 1 is 9, and then I have a little extra carryover. I'm sorry, 6 times 1 is 6 plus the 3. So 36, there's my 9 that I am thinking in my head. Subtract, have 12 left over, that's okay. Now annex your decimal and a 0. Keep going. If I have 120, using about, I need a little bit more. Let's try 7, so I'll still be less than 7 times 6, 42. 7, 8, 9, 10, 11. Okay. 112 and 120, that's 8. Keep going. Annex another 0 and bring it down. Notice these just keep coming. We could keep going. Should we? No. Divide 80 by 16. Oh, now I know this one is actually 5. 5 times 6, there's my 30. And then I get that 3 again. 5 times 1 is 5 plus 3 is 8. Exact. Yay. Hello, bub. So 6.75. So what does that mean? Well, 6.75 pieces. So how many of the shorter pieces can she cut? Well, does 75 hundredths of a piece make a full piece? No, it doesn't. So she can cut 6 pieces. Okay. Now, what do you do with that? The 0.75 is scrap. Okay, so that's not usable for her craft, okay, or for her whatever she's making. Okay, so she'll hold on to that for her next project. Okay, last one. Jenny filled, I gotta check the time. I'm super curious. It seems like a long time. Okay, Jenny filled 12 pitchers with an equal amount of lemonade in each. The total amount of lemonade in the 12 pitchers total, they're giving this to you, was 41.4 liters. We know there are 12 pitchers. How many liters of lemonade would be in 7 pitchers? Sounds like a tape diagram to me. Okay, so even though they don't require it, it's just really, really good if you guys get used to making tape diagrams. She filled 12 pitchers, so you can go like this. 1, 2, 12. 12 pitchers with the equal amount that we don't know, but the total amount of lemonade in the 12 pitchers was, you can even just go like that, 41.4 liters. Okay, how many liters of lemonade would be in 7 pitchers? Well, it'd be nice if we knew how much was in 1 pitcher so that we could determine the 7. So in order to do that, we're going to take our 41.4, divide by the 12 that we have, and then we'll have the amount in each one. So I know 12 times 3 is 36, and that gets me as close as I can without going over to 41. I have 5 left over. Bring down my 4/10, and I can get one more, so that would be 4 12s for 48, which leaves me with 6, and that means I get to annex a 0 and drop that thing down. And look, 12 times 5 is 60. You know, I got to tell you, when you start knowing your multiples, life is grand. Okay, so 3.45 liters in each, or 1, however you want to do that. But we don't want 1, we want 7. So we're going to take our 3.45 and multiply by 7 pitchers. And 5 times 7, or 7 times 5, I should say, 35, 28, 29, 30, 31, 21, 22, 24. Hundredths times 1 is hundredths. So 24 and 15 hundredths liters of lemonade. Yay! Click subscribe. Come back again. I hope I'm helping you. It is nice to have a little resource, right? Okay, and 7 pitchers. There's your answer. Yay! Oh, you probably can't see that. It's nice to be able to see, Mrs. Setness. There you go. Now you can see it. You can pause if needed. I hope this is helpful. We'll see you on the next video. You know what I'm going to do? Thank goodness this page is intentionally left blank. We're done. Bye for now.